Electric vehicles are gaining popularity due to several reasons. Many individuals are attracted to these vehicles because they emit less pollution compared to gasoline-powered cars, making them eco-friendly, particularly in urban areas. Fuel cell-powered cars are also classified as electric cars and have recently received significant attention. An electric car is propelled by an electric motor instead of an internal combustion engine. It is challenging to identify an electric car by merely looking at it from the outside. In most cases, gasoline cars are converted into electric cars, making it difficult to distinguish them from their gasoline-powered counterparts. One characteristic that sets electric vehicles apart is their nearly silent operation. This video will explain how an electric vehicle operates, including its components and their respective functions. Electric cars, which are also called EVs, are not reliant on internal combustion engines to function. Instead, they are propelled by an electric motor as opposed to a gasoline-powered engine. The motor receives power from a controller, which manages the amount of energy based on how much the driver presses down on the accelerator pedal. These vehicles use rechargeable batteries that store energy and can be charged using regular household electricity. Electric vehicles are less noisy than conventional vehicles on the road since they don't burn any gasoline or emit any toxic exhaust fumes. Electric vehicles operate similar to automatic cars as they have both forward and reverse modes. When the driver selects the gear and presses the accelerator pedal, a sequence of events takes place. The DC power from the battery is transformed into AC power for the electric motor. The accelerator pedal sends a message to the controller, which adjusts the frequency of the AC power delivered to the motor to control the vehicle's speed. The vehicle is propelled by the motor, which is connected to the wheels by a gear and turns. When the brakes are applied or when the vehicle is slowing down, the motor acts as an alternator, generating electricity, which is sent back to the battery. To understand the functioning of an electric vehicle, it is essential to know the fundamental components of an electric motor, which begins with understanding the concepts of its two main parts, the stator and the rotor. Electric motors are based on the principles of electromagnetism, which states that a current-carrying conductor placed in a magnetic field experiences a force that causes it to move. Electric motors consist of a stator, which generates a magnetic field, and a rotor, which is an electromagnet that rotates inside the stator. When an electric current flows through the stator, it creates a magnetic field that induces a magnetic force on the rotor, causing it to rotate and generate mechanical motion. Because electric cars do not use combustion to produce mechanical motion, they are cleaner and more energy efficient than traditional gasoline-powered cars. In addition to the electric motor, there are a number of other indispensable components that we would now like to explain, as without them, electric driving would not be possible in the first place. The battery is one of the most important components of an electric vehicle, as it is responsible for storing the energy that powers the vehicle. It is a large, rechargeable battery pack that is made up of hundreds or thousands of individual lithium-ion cells that are connected together in a series or parallel configuration. The battery pack is usually located in the floor of the vehicle, which helps to lower the center of gravity and improve stability. The battery pack's capacity, measured in kilowatt-hours, determines the range of the vehicle on a single charge. A typical electric vehicle may have a battery pack capacity of anywhere from 30 kilowatt-hours to over 100 kilowatt-hours, depending on the vehicle's size and intended use. Furthermore, the battery is equipped with a battery management system that monitors and controls the battery's temperature, voltage, and current. The BMS helps to ensure that the battery operates safely and efficiently by preventing overcharging or over-discharging of individual cells, which could lead to cell damage or even a fire. The BMS communicates this information to the vehicle's computer system, allowing for efficient and safe operation of the battery and extended battery lifespan. Next, we have the electric motor. The motor converts electrical energy from the battery into mechanical energy that powers the wheels. There are two main types of electric motors used in electric vehicles: AC induction motors and permanent magnet motors. Both types of motors have their advantages and disadvantages, but they all have high torque and a low rotational speed, providing smooth and efficient acceleration. In addition to converting DC power from the battery into AC power for the electric motor, the inverter also plays a critical role in regulating the flow of power between the battery and the motor. It monitors the voltage and current levels of both the battery and the motor, ensuring that they are operating within safe and optimal ranges. The inverter also allows for regenerative braking in electric vehicles. When the driver applies the brakes, the motor operates in reverse, generating electricity and sending it back to the battery. The inverter controls the flow of this energy, ensuring that it is stored in the battery for later use. Moreover, the inverter is designed to withstand the high temperatures and vibrations associated with the electric vehicle's operation. It is often located near the motor or the battery pack, where it can be exposed to extreme conditions. Therefore, it needs to be robust and reliable to ensure the vehicle's safety and longevity. An essential part of an electric vehicle's power electronics system is the DC-DC converter. Without it, the high-voltage DC power from the battery pack cannot be converted to the low-voltage DC power needed to operate the vehicle's accessories. One of the main advantages of the DC-DC converter is that it helps optimize the efficiency of the vehicle's electrical system. By stepping down the voltage of the electrical system, the converter reduces power losses and improves overall efficiency. This not only extends the range of the vehicle, but also reduces the load on the battery, which can improve its lifespan. The simplicity of the transmission in an electric vehicle is due to the unique characteristics of the electric motor. Unlike a gasoline engine, which requires a complex transmission system to shift gears, the electric motor delivers maximum torque instantly and continuously, making it unnecessary to change gears. In fact, the single-speed transmission in an electric vehicle offers several advantages over a traditional transmission. For one, it simplifies the overall design of the vehicle, reducing the number of moving parts and the likelihood of mechanical failure. This not only improves reliability, but also lowers maintenance costs. The onboard charger is what enables the battery to be recharged. There are 3 types of chargers: Level 1, Level 2, and Level 3. Level 1 chargers are the slowest, as they plug into a standard 120-volt outlet and take around 8 to 12 hours to charge a fully depleted battery. Level 2 chargers use a 240-volt power supply and can charge a battery in around 4 to 6 hours. Level 3 chargers, also known as DC fast chargers, can charge a battery to 80% capacity in around 30 minutes. The onboard charger typically consists of a power conversion module, control electronics, and a charging port. The charging port is located on the outside of the vehicle and is used to connect the EV to the charging station. Most modern electric vehicles are equipped with onboard chargers that are capable of charging the battery pack at different rates, depending on the charging station's output and the vehicle's battery capacity. In conclusion, the components of an electric vehicle work together to provide a smooth, efficient, and eco-friendly driving experience. The battery stores the energy, the electric motor converts it into mechanical energy, the inverter controls the motor's speed and torque, the DC-DC converter powers the vehicle's accessories, the transmission simplifies the driving experience, the charger replenishes the battery, and the regenerative braking system helps to extend the vehicle's range. As technology continues to evolve, we can expect even more innovative components to be added to electric vehicles in the future, further improving their performance and sustainability. So that's it for today. What do you think are the biggest challenges facing the electric vehicle industry, and how can we overcome them? Let us know in the comments below. We really appreciate your support of our channel, and thank you for taking the time to watch our videos. If you enjoyed this content, please show your support by leaving us a like, sharing the video, and subscribing to our channel. Don't forget to ring the bell to stay up to date with all the latest developments in EVs and green technology. Once again, thank you for your support, and we hope to see you again soon.